Hello, Flat Earth researchers, debaters, and debunkers. I'm going to go through 11 arguments that are presented often as evidence for the belief that we live on a spinning globe, and that is part of a heliocentric model to represent our reality. I'm answering this from the perspective of someone who realizes that we don't, in fact, live on the heliocentric model that is presented to us, but then I'm also not implying that we need to jump into an alternative belief, such as the idea that we are on a flat Earth floating in space, or a disk that has an ice wall and a dome. So this is just the only assumption I'm making is that what we experience here on Earth is that, and what we see in the sky are observations that we really do not know how it all works or where we are in space. So the true dimensions or size or mass or whatever of the Earth remains a complete mystery. So there are no alternative explanations on my part as to what this place is, or the extent or limits to what this place is either, or whether there's a dome or a firmament on top of us. So all I'm relating here is trying to help detach from the idea that we live on a globe Earth, but leave it completely open to exploration as to exactly what this place is and possibly where it is. But that's maybe something we would never know the answer to. So that remains an open-ended question. The Earth could be something much, much larger and vaster than we've ever been led to believe, simply by making observations in the sky and translating that into a globe in a heliocentric model. So these will come up as I go through the arguments that are presented here. So we'll just go through this, and like I said, I won't necessarily give alternative explanations, but will at least hopefully help to see how these observations are not evidence of anything in particular, and there are other ways we can consider the answers as to what's actually going on. Evidence the Earth is a rotating sphere and there is no dome over it. Except obviously the satellite videos, all the rest is evidence collected personally by the author, R. Maurer. Literally anyone can, with a modicum of effort and of travel, make the same or similar observations. Okay, so again, there's no denying that we all make these same observations. The point is that it's looking up at the sky and making assumptions that has led us to this globe Earth model. So in the red here, for those of you who are conspiracy buffs and think all space agencies in the world are accomplices in a vast hoax, just skip the first paragraph. The rest of the text from point 2 on does not refer to videos from space agencies at all, only to my personal observations with the naked eye, binoculars, or a telescope. So that's cool, actually, to discern the difference between personal observations that are made and are some kind of confirmation that what we are told we see is what we see. However, of course, there is the assumption there that this conspiracy to have us believe in a globe Earth is so vast that it would just be impossible to keep covered up. And this is often the first thought that pops into someone's head. What about all those people working for space agencies, etc.? Well, first of all the different countries involved, it doesn't matter. What the space industry is an excellent business model that any country can adopt as a way to get funding from the government, which is, of course, taken from the taxpayers, and then, build actual machines, boxes that will collect information, cameras, build all that, use real technology to make boxes that will be put up into the sky and fired up in rockets. That's all good, but then what we then have is a belief about what's actually happening with everything that's being sent up into space. So the politicians like this because then it gives them, they can create jobs out of the space industry. And as I said, the funding comes from the public, and all those people that are involved are doing usually very compartmentalized jobs. So they're doing something they are good at or they enjoy. They are part of a big project, this whole kind of space exploration thing. And so there's no reason to question whether what they're doing is not actually happening. As far as they're concerned, they're building the parts, they're getting paid, they have a job to do, they have a career, they have a mission as part of a team to accomplish something. So there is no reason to question really the motives or what happens after their machine is sent up into the skies. So it's easy enough to carry this out with very few people actually in the know. A huge number of people can be working on a project, and all of them believe that they are going to send a satellite up into space in the way we have been taught to perceive it, and then gather information. So satellite videos. Some satellites take pictures and sometimes even real-time movies of the Earth, which you can easily find and watch. For example, here are two beautiful time lapses made from sequences of such images. No, NASA, a Japanese satellite, a Russian satellite. And so we'll just have a look at these. And this is time lapse of Earth from geostationary orbit. So one thing that's obvious here is that we don't see where the Earth is, we don't see any stars, we don't see anything else going on. We see a static image of a globe Earth. That is easy enough to create. It could be from real pictures, it could just be created from software. And you'll notice as the transition from day to night occurs, we don't have lights in the cities showing up. And if this is supposed to be a satellite looking at weather, then it should be able to spot things like lightning storms, etc. But this is all we get. We get complete blackness at night, which is not how the Earth looks above populated cities, of which there are many. So we should see some lights here. We don't. And so basically these clouds, of course, can be computer generated, CGI. The technology to do that has been around since the 1980s, I think, when people presenting the weather on TV would stand in front of a green screen and they would do this, and these CGI clouds would be swirling away on a picture of the country in the background. And all that really is data collected from all the weather satellites on the ground and maybe from weather balloons. And the data is then translated into this imagery. So it's collating the data from various sources and putting it in together that something makes sense to our eyes. And weather radar, for example, can see for many hundreds of kilometers or miles, much more than should be possible if there's a hump or a bulge or a drop of curvature in front of that satellite. So they can actually see a very long way. All you need to do is bring that information together with some software and hardware and create your CGI to go over your CGI globe here. So that's really all that needs to be done. Sure, they could create the satellite or what would be some kind of weather balloon or something, put it in a rocket, shoot it up into space. Where it goes after that, nobody really knows, but this is the information that they get back from what they believe is a satellite floating in hundreds of miles above the Earth's surface. So yeah, it's certainly, there's no real indication at all that this is a real image in any way, shape or form. The other link was this one, and this is even worse, really. We have part of the Earth visible. It doesn't even, I mean, Thailand, I can tell you for sure, is not this color. It's mostly green. I'm not sure if any specific color filters or whatever have been added to this, but this could be, again, something taken from a very high altitude. It could be a lot of images stitched together. It just could be a complete composite that is not from real photographs at all. And again, we just have the same thing going on here with the clouds are just a digital representation of the data that is collected from all the weather stations around the world. And of course, they all do communicate. And again, we see as it gets dark, we don't see any lights coming up from the cities or anything like that. So this, again, if you're going to spend billions and billions of dollars sending satellites up there to see the Earth from above, then you could and should incorporate all the tools necessary for us to really see what's going on. So this is clearly just a representation of data collected on the Earth, or maybe just above it. And here again, we have, this is from the Himawari. It's supposed to be real time, every 10 minutes. Again, it's perfectly feasible for the weather data information to be collated. I mean, if you think about the supercomputers that monitor or operate the stock exchange, the World Stock Exchange, I mean, they are updating by the nanosecond the information that's coming in from the stock markets around the world, and those computers are making decisions, etc., and translating that information into graphic displays and what have you. So all this, I mean, within 10 minutes, a whole new picture can be created from all the data gathered around the Earth, on the Earth, or just above the Earth, to present this image to us. So again, it gets dark, we don't see any lights coming on, we don't see where the Earth is supposed to be in space. None of that is presented to us. We're just given an image with a very scarlet Australia there. And, yeah, so really these are not in any way evidence at all. So it hasn't been ignored, it has been looked at. And of course, I know that most of us watching this will have already been through these questions ourselves, because to realize that we're not on a spinning globe, you have to question it first, and then you go to see what answers we are really given. Look closely at the answers. So, number two, naked eye observation of artificial satellites. Nowadays, there are literally thousands of satellites orbiting the Earth, and you can easily see the brightest ones with your naked eyes passing overhead. Iridium flares are spectacular and are predicted to the second. See this link here. If there's a dome, what are those things, and why can we predict their passage with such precision, with a globe model and gravity as basics? Using the site mentioned above, I have observed many times satellites passing overhead at the predicted times, and also iridium flares. All this is easily visible to the naked eye, as said before. Okay, so the fact that you can see it with the naked eye shows that these things are happening fairly close to us. That's for starters. And no one is denying that we can make these observations of what are called satellites. Now, the word satellite just means a smaller body next to the bigger one. You can have a satellite city is just it's kind of on the outskirts or separate from the main city. So the meaning of the word satellite just means a smaller version, or a small object that is somewhere around the outside of the larger one. So, of course, we are led to believe that satellites are these boxes that are shot up into the air, and because of the speed they are going and the distance they are away from the Earth, they will naturally just follow this curve of a globe Earth without any resistance, because there's a vacuum in space. Okay, so this, we understand the theory, and it would all appear to be what many would consider a working model. So the observations are there, but what we are probably talking about are balloons. Now, if you look back at how NASA first got into satellites, or what they made public, was Echo 1, a huge balloon that took up an entire hangar, I think, filled with helium. But that wasn't filled up until it was first shot up in a rocket high up into the upper layers, and then the balloon was inflated and left to hang there. And this was apparently very successful. They were able to bounce signals to and from the balloon. They were able to receive signals from it. And all that really needs to be happening there is for that balloon with the box of tricks suspended beneath it, just doing what any hot air balloon does, or any helium balloon does, and that it reaches a density that is equal to the layer of air, the density of the air or the gases around it, and then it just hangs there, and it becomes part of the environment. So if you've ever been up in a hot air balloon, you'll notice that you don't get wind in your face, because if there is any wind, you travel along with the wind. And of course you can change your direction by going up or down, where the wind in different layers is going in different directions. So that's how a hot air balloon maneuvers. But you don't ever feel the wind on your face, because you're not going against or with you're just going with the wind. And if there is no wind, then you just hang there. So the fact that NASA's satellite program started with balloons and then called them satellites is how it may well have carried on. So yes, there are satellites up there, but they are suspended on balloons. This has been evidenced with devices that look just like satellites crash landing in places with a massive balloon on them. So you could get a balloon that travels around with a jet stream. So as long as that jet stream is a fairly constant thing, then you will be able to make predictions as to when that balloon will come around again. So again, this can all be happening above a flat Earth. It doesn't need to be orbiting a circular Earth with these massive speeds. It just goes around with a jet stream, and there are jet streams going in different directions at different heights. They don't only go one way in a particular hemisphere or either side of the equator. And then maybe above that you have stillness. Maybe you don't have winds. So if you put up a helium balloon that was large enough to expand enough to reach an equilibrium with the air around it, which is going to be very much less dense air, and possibly with a lot more helium in it, because that's a noble gas that will rise up. It's lighter than air gas, so it makes sense that you would have layers of air that are comprised of a more of a lighter gas than the other gases. So the observations of satellites are predictable. There's no debate or argument there. So yes, there are things up in the sky there, and it might well be that once they're up there, they just stay there. And number 3, rotation of the celestial poles. The stars in the sky around the northern hemisphere, Pole Star, Polaris, Little and Big Dipper, Cassiopeia, 47 degrees up in the sky, that is halfway up. Where I live, revolve 15 degrees an hour counterclockwise, like the hands of a clock, with Polaris as axis only counterclockwise. However, the stars around the southern celestial pole, constellation Crux, up in the sky too revolve clockwise. I've seen this myself with my own unaided eyes in Switzerland and in Argentina. In Argentina, I was near Mendoza. So the southern celestial pole was 33 degrees up in the sky. It only takes a little patience to look at the sky at, say, 1 hour intervals to observe this. There is no way this counter-rotation is possible if the Earth is not a rotating sphere. Else, state how. If you think the sky can behave like that above a flat Earth, please explain how. Hint, it could only work if the sky were made of some sort of jelly deforming in a kind of 8 pattern. Yet the constellations affixed to it would in no way get deformed, not even a thousandth of an arc degree. I have a hard time thinking that the sky is made up of such magical jelly. Okay, yeah, it's obviously does your head in. A few things to respond there. Magical jelly, whatever. I mean, astrophysicists and scientists are still scratching their heads now to work out what 99.9% of everything else is that we can't really see around us. And of course, it's referred to as dark matter. So there is this reference to us being in some kind of soupy mixture, or space being some kind of liquidy soup or matter of which they know nothing about. So you have a hard time, scientists have a hard time trying to work out what this all is anyway. So no worries there. The poles, looking at the pole star, it works fine on a flat stationary Earth too, if these things are moving. We don't decide what is supposed to be going on up there. That's the mechanics of it is not up to us. It's not something we've worked out. All we've done is measure the passage of time and make observations. So yeah, it's there's two ways you can look at this. If you imagine that all the stars are rotating like a ceiling fan, and you are north of the equator, then if you looked up towards the north, towards the center of that fan, you would see just a section of the fan in your field of view. And so for me, looking up like this, if I was looking up at the fan, if it would be coming in from my right and going off to my left if it was rotating in that direction. But to call it clockwise or anti-clockwise is really dependent on our perspective. So if I'm looking up this way and it's all coming in from the right, going out to the left as it turns, it's still turning like that. So of course, if I look up here this way, then everything is coming in from the left now and exiting to the right of my field of view, even though it's all rotating in the same manner. So that's one explanation. And the fact that if you're, say, on the equator and you're looking south and you see what appears to be a pole in the south because you don't see the stars moving, that's just perspective. Again, if the stars are all close to us and we, so we watch something that's go above our heads, it will do a long arc, but the further away something is, the less it will appear to move across the sky. So everything could be moving in uniform across the sky, but it's just like looking down a tunnel. The walls above us, the ceiling above us will be very visible, and we can have this very sweeping arc for looking at everything that's close to us, but everything that's further away, we don't need to do this sweeping arc. So that's another way. Or we could in fact have, as he says, a figure 8 pattern going on with two poles, one at either end, or they're just points that we can observe these rotations going on somewhere on the Earth. They don't need to designate the boundaries of the Earth. They've just been used in that way to create the globe. But they could be, it's if we're on a flat surface and we look up at the sky above us, whatever's happening above us can't be seen by someone 200-300 miles away. You could look across the surface and you would see the clouds, for example, hit the horizon. Maybe it could be anything from 1 to 200 or 300 miles away, but that's it. Someone else who's that far away from you, or even further, will be looking at their own version of the sky, and they won't have a clue as to what you can see over here. 400 miles away. So even across a flat plain, you look up, you're going to see a different scene to what someone not very far away will see, even on a level plain with the clouds, the sun, the stars, all very close and local to us. Not in a dome, but in a kind of sandwiched layer. And of course, we didn't write the laws of the mechanics of the universe. It did that itself, and we just really just don't understand it. The figure 8 is interesting because that represents the infinity symbol. So it could well be doing this figure 8 as a representation of this infinite cycle. We do see that with the what's it called now, when you take a photograph of the moon at midday from a given location, and over the year it creates a figure 8 pattern on that time-lapse photograph. Can't remember the name of that, but yeah. So we see a figure 8 going on in the sky. It doesn't mean that we're on a globe, and it doesn't mean that we are moving, and we just have to realize, and we can accept that we make these observations and they work, and we can predict things from them, but that's all we can do because it's just observations. To assume anything more about the mechanics of it all is literally that. It's an assumption. And it is all down to interpretation. Number 4, stars only visible from northern or southern hemisphere. Okay, so from the middle of Argentina or South Africa, it's never possible to see Polaris, right? Basically, so if you're beyond the equator, then you can't see Polaris. And vice versa, if you're north of the equator, you can't see the southern stars. That's basically what this paragraph is saying. And again, this, you just have to realize that the stars are close, and the further away we get from any particular star, the closer it will appear to be towards the horizon, until eventually it is obscured by the horizon. It just goes beyond anywhere that we can see. Yeah. So remembering our horizon could comprise entire mountains, that the angular size in our field of view has decreased so much that we just can't make them out anymore. And it wouldn't matter how good any optical instrument would be to see that any more clearly. You wouldn't. They're just part of the horizon. There's just a limit to how far we can see across the surface. So yeah, again, it's just perspective and the understanding that you can explain it as everything being in layers that are close to us. So it is, it says here, this is possible on a sphere, but not on a disk. Or no, again, because it's all to do with perspective. So the globe is a conversion of the perspective used in observations and translated into a curved surface, especially when it comes to things like looking at Polaris. So, okay, there are other questions that I can expand on that a bit further. By the way, the corollary observation is that the elevation of the sun at solar noon on any given day is related to latitude in a linear way. Early navigators used a sextant to measure latitude by this means. A sextant would not work correctly on a flat Earth. No, again, it does. A sextant is basically making observations, and you use the horizon to make observations of where the sun or a celestial object is, how many degrees above the horizon it is. But again, the number of degrees above the horizon will depend on how close you are to it. So, of course, if it's something overhead, then it will be 90 degrees. You don't have to be on a globe for that to happen at all. And the early navigators did use sextants, and they work. There's no denying that they work, along with the astrolabes. But this is at a time, remember, when we're told that they thought the Earth was flat, but they still managed to navigate because they were using this equipment, which just basically relies on observation. So yes, latitude lines have been assigned or designated based on the distance from the North Star, which is obviously something we can rely on being in the same position all the time and visible anywhere on the north of the equator. So yeah, it makes for a great reference point, but it doesn't. It doesn't make the Earth spherical. The diameter from which we go from the north out towards the equator is basically the limit of where we would see this local star in our field of view in the sky. Remembering that the sky is transparent, whereas the Earth is not. The Earth is solid, and when we look straight ahead across a flat surface, then of course the surface appears to rise to our eye level, and so it will cut off things that are in the sky, or eventually reach that point in our field of view that is at the center of our field of view, and just go beyond the limits of what we can see. So there's that one. Yeah, 5. Night skies in summer and winter are different. Get out, say at 11 o'clock, 11 p.m. in the summer, and look at the stars in the south. Take a picture of them. 6 months later in winter, get out at 11 p.m. and take another picture towards the sun. Compare the two pictures. They are entirely different. You can't even match a single constellation. Being an amateur astronomer, I have seen with my own eyes and telescope that the winter and summer skies are entirely different. Why would that be the case on the firmament? In contrast, it's readily explained by the fact that the Earth is rotating on itself and rotating around the sun. It's easy to understand if you draw the situation. In space at 11 p.m. you are actually looking in exactly opposite directions in winter and in summer. So for example, beautiful Orion is plainly visible during winter nights, but can't be observed during summer nights. Some of you will say, but Polaris can be seen all year long, and they will be right. The reason is that Polaris, and to a lesser degree neighboring constellations, are located on the same line as the Earth's rotation axis, and they are very far away, about 323 light years for Polaris, that is, or whatever that number is. Again, if you draw the situation, it will become clear why Polaris up in the northern sky remains visible all year, while Orion, low in the northern sky in winter, does not. Okay, so nobody can ever draw something that's really to the scale that you're talking about here, 323 light years. So of course, it has to be assumed, and it can of course be calculated for a model, that the stars are each billions of miles away, or light years from us and from each other, in order to explain how it's possible to be on a spinning globe and not see this convergence of stars that are in different layers or different distances. So they have to put them so far away from us and from each other that that's the explanation for why we don't see any change in the parallax of the stars and what have you, or for the model. But these are, you know, the astronomical unit, for example, is something that was debated in universities across the Earth for about 20 years, and they eventually settled on a number that wasn't any kind of measurement. It was just a number that fits with all the calculations for the models the most accurately. You still have to round things off, but this is a thing they were arguing about for decades, and usually just based on it was an ego thing about who came up with what number and which university they were attached to, etc. So it's been a very, you know, to decide on an astronomical unit, a form of what you might call measurement, but is actually only calculation to describe the distances between celestial objects such as the Earth and the Sun, is again, it's just made up stuff. It's not based in any factual, measurable proof at all. Now, the fact that the night skies in summer and winter are different in the northern hemisphere is just, again, easily explainable with if you're able to detach from the idea that the Earth is moving. So you have to understand that the only reason that we have a spherical spinning Earth is because we have this idea that the sun is at the center, this heliocentric model. So in order to justify the transition from day to night, you need to have a spherical Earth if you are going to have the Earth orbiting the sun. If you're going to put the sun at the center, the Earth naturally has to orbit it, and the only way that you can get this transition from day to night is to have the Earth as a spinning sphere. And so you have parts of it always facing the sun, and the other part always facing deep space. But of course, what's happening is everything's working separately. So the sun, moon, and stars, and the Earth, they're all separate entities, but they are like a clock. They are cogs in the clock that are rotating at different speeds as part of a larger mechanism, a time piece, as it were. So the planets, they're all doing their own orbits of the sun, if you like, and the moon is doing its circle, and the sun is doing its thing, and the stars are in possibly one or two layers above us that are all moving together. As long as you can separate these into layers of celestial objects that are moving in whatever fashion they do in their own time, then you can realize that you just don't see the stars at the same time in, say, the winter, because it just depends what the sun is doing. The time, 11 p.m., for example, is something that we've constructed as an idea, as a concept to follow. It's not, for the Earth or for the sun or for the stars. 11 o'clock means nothing to it. It's just our time, which is created by 12-hour, 24-hour segments of hours from the last one. So we all get off with our timing, really. I mean, so you just in the summer it's light until maybe 10 p.m. Whereas in the UK, for example, whereas in the winter it gets dark at around 4 or 5 p.m. So, of course, the stars that you see at these different times are going to be different. And it's just because if the stars are rotating in their own pace, and the sun is doing a different pace, then, of course, the times that you do or do not see stars just depends on whether the sun is near you or not. And once the sun's gone away, then you can see the stars. Again, it doesn't mean that we're on a rotating sphere, but you can put yourself anywhere. That's the beauty of these models, is that you can make any model you like from the observations, and you can put the moon at the center, or you can put the Earth at the center, and as long as you just are illustrating the passage of time based on the observations that we make from the Earth, you can create other models with other entities at the center of those models, and then of course you would have to assume that the Earth or the moon or the sun or whatever is doing something in particular in order to fit with the model. So that's all these explanations ever are. They are called scientific explanations, but they're not. They are just explanations of calculations that are made for a model. And then, we are told things like, well, did you know the Earth is spinning at 1,000 miles an hour and it's going around the sun at 66,000 miles an hour? Of course, it's not really doing that at all. But that's what you have to assume, or you calculate into the model, and it would appear to be precise, and it would be a working model, because okay, that time and that speed and that distance fits with this idea and this. So again, just saying that a planet or a moon is a certain distance from the Earth is just an assumption as well, because you all you've done is measure the time that you observe it come into view or go out of view, and then you've got that as your constant, and then you can apply a different speed or a different distance because of things like perspective, etc. Yeah, the further away something is, the longer it's going to take at a greater speed to cross your horizon. So you can calculate all that in. you just make those models. Yeah, so ridiculous numbers are necessary. In fact, if we were on a globe and we were looking at these stars, they would all get jumbled up and crisscross and everything as we rotated. 6, shape of the Earth's shadow on the moon. Again, that's just an assumption. It's an amazingly one of the foundations of the globe Earth proofs. The shape of the Earth's shadow on the moon. Of course, we never see an entire circular shape within the confines of the moon's surface. We just see what appears to be the edge of a very large dark shadow go across the moon. Could be anything. Often we see the moon and the sun still above the horizon, so this of course means that the moon is not between these two, the Earth is not in between the moon and the sun in that case. So just the fact that we see what appears to be part of a circular shadow is not, it's not any kind of proof at all. It's just an assumption that that's what's happening because it's an observation that we can make. 7, simple astronomical observations of planets. I can see Jupiter, obviously a sphere, with its 4 largest satellites, Io, Europa, Ganymede, and Callisto, slowly orbiting it with my own telescope, a $1,500 Meade with very crisp Cassegrain optics. If Jupiter is somehow glued to a dome, what are its satellites? Well, yeah, whatever Jupiter is, and if it has lights or rocks orbiting it, then fine. It doesn't mean that that's what's happening with the Earth. Again, we don't have to assume that the Earth is another planet in a solar system. Well, we do if we assume that the Sun is at the center. So Venus has phases like the Moon: full Venus, crescent Venus, gibbous Venus. When conditions are good, I can even see that with good binoculars. If Venus is somehow glued to a dome, how is this possible? Especially, how is it possible that at some times Venus is a crescent and at others an almost full disk? And why hasn't Jupiter phases like Venus? The reason is that the orbit of Venus is inside the orbit of Earth, i.e. closer to the Sun, which means we sometimes see Venus from its side, 90 degrees from the Sun. That is half lit. While the orbit of Jupiter is outside that of the Earth, and so we always see the Sun facing side of Jupiter. Okay, again, all just interpretations of the observations. Venus just could well be like another moon, just further away from us. Of course, these, again, we're looking at what is quite possibly just a few layers of these planets and stars doing their orbits of the Sun or each other above us, and we just interpret it because of what we can see. So this could indicate that we are on a much larger plane than we are led to believe. All we know is the maps that we've been given with this coordinate system plonked on top and then called a sphere. We really wouldn't know what was beyond that. So we could be watching moons and stars, whatever, circling above land that we just don't know about, that is way beyond what we've ever been told has been discovered so far. So that really, again, it's not an explanation that has any kind of proof, but it's definitely a possibility once you are free from the idea that we are stuck on a spinning globe. Right, next one. 8. Sun setting over large bodies of water. The sun sets over big lakes and oceans. It does never vanish to a point or somehow gets switched off. I have watched countless ocean sunsets. Every time the sun disappeared in a matter of minutes behind the water horizon, while remaining an unchanged and perfectly visible disk. More generally, sunsets are a common experience of coast-dwelling people, so billions of people have seen billions of sunsets. And no one has ever filmed a shrinking sun. They have, actually, or whatever. other nonsense. In some rare circumstances, the sun in videos can appear to shrink, but this is an effect of overexposure. The glare makes a large blob on the film camera sensor, and the blob then shrinks as the sun sets. With a dark filter on the camera lens, this thing does not happen. Anyway, the common observation which one can make every time the water horizon is free of clouds is that the sun sets on the water and disappears bottom first, top last, without changing dimension, bar some flattening due to refraction sometimes. Where does it set in a domed Earth? Okay, so again, putting aside the assumption of a dome, it really is just perspective. If we've got a local sun, and if you look straight ahead across a flat surface, that surface will of course be solid and will take up the bottom half of your field of view. Can't see anything that's gone beyond it. But if you really just consider that we have the Earth as one layer, we have a layer of sky, then we have clouds, and then we have the sun somewhere above that. So we know that if we look at clouds in the distance, they appear to touch the horizon. They don't have to be very far away. Those clouds could be just, I don't know, 100, 200, 300 miles away, and they would be on our horizon, in our dome of perspective. Yeah. Again, the dome would be, actually, we would have a sphere of perspective, our own personal sphere of perspective. But of course, the flat surface is taking, it's not transparent. The sky is transparent, but the lower half of this dome of perspective is solid Earth usually. So the horizon is going to be at our eye level. And so, yeah, the three layers, the Earth, the clouds, and the sun. So the sun, the clouds get to a distance where they meet the horizon. You're never going to see the clouds beyond that, even if across a flat surface. And then the sun above those clouds. So the clouds reach the horizon first, and then the sun. Now, he did mention without clouds, but it still works out the same. The air is just thick and dense, especially close to the surface. So the further we look across the surface, eventually there's going to be a limit to where we can see. Light will not reach our eyes, and everything we see is based on light, reflected light. We see colors because of the light reflected from whatever is in front of us. If the space between us is a thick soup, it's dense with air, moisture, dust, what have you, everything that we know is in the air, then that will be a barrier. Just try to imagine, you look through even the clearest water. If you look through really clear water, crystal clear water, there is going to be a limit to which we can see through that water. It eventually just becomes dark. So yeah, it will disappear and appear to be a disk. What the sun is, nobody knows. And we see a circle because of the geometry of our eyes, perspective. We have spherical eyes, and they have convex lenses, and so everything we see is governed by perspective, and that can be described in terms of geometry to talk about how we visualize three-dimensional or multi-dimensional space around us. It's just perspective. So the sun does sometimes, if you can see it far enough, it depends on conditions. If the air isn't full of moisture, and so in dry conditions we often do see the sun shrink. But when we're looking across water, then no, you're going to have a lot of vapor, and it's going to create lensing and distortion and eventually block off your view of the sun. So that's that. Right, it doesn't scroll down anymore. Number 9, distant ships, etc. on lake, buildings on opposite shore, not visible. Ships partially or fully disappear beyond the horizon depending on distance. Even on 37 kilometers, 20 miles long lake, Neuchâtel, Switzerland, where I live, I can see this very easily with a good pair of binoculars set on a tripod for clarity. Explain this. No, they don't suddenly shrink to a point or get erased with distance, and switching to my other, more powerful pair of binoculars does not bring them back. If something's gone beyond the horizon, then no, you won't bring it back, because again, the surface is solid. So it doesn't matter, you know, zooming in, this whole response about zooming in is one aspect of this, is that we may look across the surface of water with the naked eye, and there is a boat on the horizon that's too small for us to see and make out with our eyes, but it's still visible. So zooming in with an optical instrument will allow us to see something that is still in our visible range on the horizon, but and isn't obscured with bad conditions. But no, you can't bring something back into view if it's already blocked by the horizon. It's no different to looking over a wall, and anything beyond that wall will be blocked eventually. So yeah, this is a confusion of the two different things that you can observe happening on a horizon. Here, in the same way, medieval Verdun Castle, 20 miles from my side of the lake and towering 121 feet above the water level, cannot be seen from this side. Why wouldn't it be visible if the earth is flat? I can see the mountains behind Verdun, but not the castle. So it's not a question of the eye can't see that far, or the haze prevents us from seeing the castle. Well, yes and no. Again, it's angular size, because 20 miles away is quite far, and the castle that's only 121 feet high will be tiny in your field of view. So anything that is even much, much smaller than the castle that is in front of you will block off the 121 meter high castle, simply because it's larger and closer to you in your vision. So a very small object in front of you that's rising up above the surface will will block your view of something much, much larger, but which has an angular size that's much, much more reduced. But of course, the mountains beyond the castle are that much more larger than the castle itself. So yes, you can still see the mountains because they are so large to start with, but they have also reduced in angular size, but they still remain in angular size larger than the castle in front of you. Yeah, so yeah, it's just, again, perspective. So when considering perspective, you have to think about everything that is in your field of view, not just the one or two objects that you're talking about, but the whole way it all works and how that all combines to give us an overall view of the Earth in front of us. Number 10, the Foucault pendulum, a very common argument that just doesn't correlate at all if you think beyond it, but let's just read it. A pendulum will oscillate in a constant rate, a constant plane, while the Earth is rotating. In other words, its vertical oscillation plane will slowly rotate relative to the Earth due to the Earth rotation. This cannot be observed with a normal small pendulum due to air currents, etc. But Leon Foucault around 1850 had the idea to test this with a very long pendulum, isolated from outside influences. To this day, Foucault's pendulum can be seen in Paris at the Conservatoire des Arts et Métiers, swinging in a slowly rotating way because the Earth is rotating underneath it, and this demonstrates it. Yeah, again, it's an assumption that the Earth is rotating beneath it. A small pendulum, yeah, is going to kind of die out in a very short time, but the length and the weight of the pendulum does obviously make a difference. But what we see happening is what happens to any object, really, that is that goes down or is prevented from going down. It's just that we see it more exaggerated in this with this Foucault's pendulum because it's so large and long. But what we see is a natural tendency for something like that to do a circle, to to go back and forth, but at the same time itself will do a circle. It does not mean that the Earth is rotating above it, so beneath it. I'm sorry, just because it's suspended on a free swivel hook. So all we are observing in this case is the natural tendency for things such as gyroscopes, the pendulum, and I think there's a few other things you can lump into there, which demonstrate the kind of the vortex action that we see taking place. There are all sorts of observations that can be made that relate to these things naturally doing spirals, basically. Now, of course, the way the Foucault's pendulum is often visualized is with a globe model. So what you actually have is a pendulum that only goes backwards and forwards like this, but if you put a rotating model spherical Earth beneath it, then of course you would get what appears to be rotation. But the idea is that if you put it on the equator as this spherical Earth rotates beneath it, then you wouldn't get the same effect that you would north of the equator. But of course there are no Foucault's pendulums on the equator. There's only one in Paris that is said to be aligned to its latitude, etc. So for this to be any kind of scientific proof, you'd have to have it demonstrating the differences at the different latitudes. And on top of that, if you consider that it is in this case accepted for the globe model that something above or independent of the rotating Earth will be free of that Earth's rotation. So you then apply the idea that the Earth can spin underneath the Foucault pendulum to an aircraft or something that is in the air independent of the Earth. So it should be the case that if the Earth is allowed to rotate freely beneath us, then we should be able to reach other destinations in a very short time as it comes to us and we travel towards it, but equally difficult to get to another direction, or you set off this way in order to reach a destination that starts off over here but will meet you as you go straight across. That doesn't happen. Flight plans are not made like that. Flight plans are made across a stationary Earth. You go from one destination to the other, and all you have to argue the fact that everything we do on or above this Earth is done as if the Earth is stationary, we have to imagine frames of reference and relativity, or we are told that, oh, the atmosphere is spinning with the Earth. It's stuck to the Earth, as it were. Well, that is a counter-argument, or it doesn't fit with this assumption that a Foucault pendulum can move freely above a rotating Earth. So you can't use the Foucault pendulum as some kind of proof and then say that, well, the atmosphere just sticks to the Earth as the Earth rotates. Doesn't work. And of course you've got the Coriolis effect as well, or Coriolis force. So you have to see if all of these descriptions and explanations or borrowed ideas from real physics and real science actually fit together in the entire model. The Coriolis force is really just an imaginary force because depending on your frame of reference, it would appear that an object thrown in a straight line would appear to take a curve depending on your frame of reference. And so the Coriolis force is not necessarily, it's not a force that makes the ball bend. The ball carries on in a straight line if you throw it while you're on a rotating platform. It's just that it appears to bend. So again, that is how gravity is referred to as a force. It's an apparent force acting on objects to make them fall, an apparent external force when you don't need an external force. You just need the mass of the object itself in a dense medium, and it will fall through that dense medium that can't support it. Less dense medium. So the object that you want to drop is dense, it's fixed in its density and mass, and it will fall through a less dense medium. Doesn't dictate the shape of our Earth, or that we have some external force pulling us towards the center of said spherical Earth. And number 11, the midnight sun. I was in Umanak, Greenland. That's 70 degrees north latitude in midsummer 2017. I could see that the sun did never set, but just skimmed the horizon, northern horizon at midnight. How is that possible on a flat Earth? Since at the same date, Europe, Mexico, India, and Australia, to name a few, still had days and nights as usual. Yeah, the sun's still doing its thing. You just change location, and the sun will still appear to sink towards the horizon because it gets further away from you, but it's not getting far enough away from you to completely set. So if you're in Greenland, if the North Pole is at the center of this known plane, and the sun is doing circles around you, and you can see the sun. Of course, it is still physically high in the sky, but to you, being somewhere in the center of this ring that the sun is doing above a level plane, then you will just see it be slightly above the horizon and then kind of wave as it goes around, because maybe at some points it's further away from you, so you're somewhere on this ellipse, or you're a little bit off center. So the sun, as it travels away from you and its furthest part of its circle, will appear to sink to the horizon. So again, it's easily explained with perspective, which of course governs all our observations on a flat Earth. So I hope that has provided some responses that will at least could be useful for someone who has the same questions. So feel free to share this, if you like, with people that feel they need some answers. But of course, the main thing is here that people want alternative answers, or they want alternative models. And really what we have to realize is that we've been given explanations for a model that is created from observations. So all we had in the first place was observations and the measuring of time. And then we've created models from that. And then we've created explanations to fit the model to go with the observations that we make. But watching the sun rise or set does not mean that the Earth is moving. It doesn't mean that we're on a sphere. Yeah, it can be interpreted in many different ways. Even Einstein admitted that there is no optical way to tell what's moving. So he, of course, realized that you can then make up theories and explanations and even equations to go with those explanations about relativity and the speed of light, because light is obviously intrinsic to making observations. So this, of course, is why it's been important to have a speed limit for light, because then there is a constant that the mathematicians can use in their model of many other variables. But once you have a constant, a foundation for your model, then of course you can create, expand on that model with mathematics. So that's all we have when it comes to the globe and the heliocentric model. A choice to put the sun at the center and model everything off that. And the calculations all appear to work out fine, and this is why people believe that we have a working model. The only thing is that, that was left for a long time was how do we stick to a sphere? How do we justify that? Oh, gravity. Gravity is just a translation of the word weight, but of course we are conditioned to perceive and believe that gravity is an external force pulling us towards the center of a spherical Earth, so that down becomes towards the center of the sphere that we imagine we are on. Yeah. Again, it's just depictions and assumptions, descriptions that appear to create a working model, but that isn't a true translation of our reality. And the truth is, we don't know. We don't have alternative answers as to the mechanics of the universe. We don't have to have an equation that fits all, because that's almost impossible. And that's where you have to begin if you're going to really seek the truth of this matter about who we are and where we are. Thank you very much.